Good afternoon, good evening, good morning to all of you. We are just about to start the webinar. The title for today's Digital Transformation Council DTC Asia webinar is on the power of digital manufacturing. This is being made live across India, Thailand, Singapore, China, Japan, and Australia. The agenda runs like this. So we are starting around 1:30 p.m. India time, so it's 4 o'clock Singapore time. The topic will be introduced by Bob Gill, General Manager Southeast Asia, ARC Advisory Group. He is now presently sitting in Singapore. And we have a speaker, Louis Schaeffer, Chief of Manufacturing Technology, Royce. I believe that he's presently based in Japan, so he's going to speak from Japan. So it's quite interesting to see the topic introduction by Bob happening from Singapore. And Luz is going to speak from Japan, and we are hosting it from Bangalore, India. Along with me, I have my colleague Elena with me, and also have a backup with Mr. Rajkumar taking the call from home. And then after the topic introduction and the speaking by Luz, we'll have a small panel discussion between Bob and ARC Advisory Group and Luz. After that, we will open it for audience Q&A. And then we intend to complete the whole webinar in about 60 minutes. After the Q&A with the ARC team, we'll have the Q&A with delegates. Please put your questions in the chat or question box. And in case you want to ask questions live, which we really do not like to have, still the organizer will unmute you, but still we suggest you put your questions in the chat and question box so that we take the questions from the speaker as well as from the ARC. Coming to the Digital Transformation Council, so Digital Transformation Council is a place to connect, collaborate, learn, share with the peers who are digitizing and transforming their organization. DTC is only meant for end users so that you can interact with peers without any hesitation. You can also have an access to library. In case you want to talk to some analyst, you can have a talk with the analyst. And also the DTC members will be able to view the forum archives of global forum which took place in February for the next 3 months. Now I'll be switching over to Bob Hill to take the topic introduction. That Bob will talk on the power of digital manufacturing. Over to you, Bob.
Okay, thank you, Raman. And yes, let's talk about manufacturing. The manufacturing industry continues to be a major contributor to economies right across Asia. It accounts for well over 20% of GDP in Southeast Asia, as well as in India, China, Japan, and Korea. I think it's interesting that last year in 2020, you know that we were all being hammered by COVID-19, yet the manufacturing sector actually held up relatively well. So for instance, here in Singapore, while the economy contracted by 5.4%, which was actually its worst performance ever on record, manufacturing output here actually increased by 7.3% compared to a year earlier. And for Vietnam, which was actually the best performing economy in Asia, in fact, one of the best performing economies in the world last year, its positive GDP growth of 2.9% was in large part due to industrial production growing at nearly 6% in order to meet strong export demand. It's also a fact that in many parts of Asia, the nature of manufacturing is changing. And I think Singapore is a prime example of this. Labor-intensive manufacturing of relatively simple products back in the 1960s has gradually been replaced over the decades to form an industry which is much more reliant on knowledge, on skills, on IT, and on automated processes. So today, it's the production of semiconductors, high-value electronics, precision engineered components, biopharmaceuticals, medical equipment, petrochemicals, and the topic of today's presentation, aerospace parts and components, which increasingly drive the manufacturing economy in Singapore. And just a few weeks ago, the Singapore government affirmed its commitment to maintaining manufacturing as a key pillar of the economy, announcing plans to grow the sector by 50% in value over the next 10 years to 2030. In order to do this, we'll require a number of things, including investment in R&D, in workforce skills training, and investing in initiatives to help companies, both large companies and smaller companies, to digitalize their manufacturing operations and digitally transform their businesses. But already today, in Singapore, there are global brand name companies that have chosen the country as the preferred location for advanced manufacturing facilities. And these make use of the many digital technologies that we've been talking about and have become increasingly available over the last few years. So that's companies like HP, like Infineon, Hyundai, Dyson, and the company that we will be hearing from today, and in fact now, Rolls-Royce. So Luke Sheffer is Chief of Manufacturing Technology and also Director of the Rolls-Royce at NTU Corporate Laboratory, which is a strategic partnership between Rolls-Royce and Nanyang Technological University, NTU, here in Singapore. So right now he will be telling us all about Rolls-Royce digital manufacturing in Singapore. So Luke, very warm welcome to you and to this month's Digital Transformation Council Asia meeting, and it's all yours. Thank you.
Okay, thanks, Bob. Can you hear me and see me?
Yes, Louis, I'm able to see you, and then
okay.
You don't have to rush your presentation. Take about 35 minutes, no problems. Okay.
Cool.
So
thank you.
We had a look at your presentation. It's very powerful. So please have it slowly so that the audience get the benefit of your time. Okay.
Okay. Thank you very much.
Lena will start sharing the screen.
Yeah. Thank you very much. Thanks, Bob, for the introduction. And yes, it is truly global. Indeed, I'm in Kobe right now in Japan. And yet Bob was in Singapore, and we're managing this presentation from India, which is very representative of the last year or so. I suppose we've learned a lot how to do things remotely and leverage the digital capabilities actually that we have now available to us. So yeah, thank you for the introduction. We have been deploying technologies in Singapore with the help of the strong support from the government. So as Bob said, manufacturing, high value manufacturing is very important for Singapore. And that translates into a lot of help that we're getting from the government and the research agencies that we have over there. The reason why I'm in Japan right now actually is to also help our suppliers. So we've got risk-sharing partners for our civil engines, and quite a few of them are in Japan. So it's the heavy industries. So KHI and MHI are some of them. Some of those programs that we've implemented in Singapore can also benefit our suppliers. So that's the reason why I'm currently based in Japan. Okay, so let's go into it. Let's go into the presentation. So let's move to the agenda. I believe is the next slide. I'll just quickly tell you what I'm gonna cover. So yeah, quickly about Rolls-Royce. I think just to give a bit more explanations about what we do, why we're driving towards digital. And I think it's important that I explain the sort of partnership model that we've got here in Singapore, because it's quite an innovative way of doing research, and it may be of interest to the audience. And then I'll finish with a few case studies. Okay, let's go to the next slide. And okay, yeah, we can go to the next one again. Thank you. So Rolls-Royce, I think most people are very familiar with the name. I often get the question whether I'm driving a Rolls Royce or I've got a Rolls Royce as a company car. The answer is no. Unfortunately, I wish I would. Especially in Singapore when you consider the price of cars over here. But the automotive section of our business was sold to a German group quite a few years back, actually. So we kept the badge and the name, but the automotive section is no more managed by us. What we change our, so I work for the power company. We've changed our strapline or our motto recently to pioneering the power that matters. So we see ourselves as a technological company trying to go for more sustainable power. So, you know, to help power the society. What you see here is actually automated system to produce composite components. So we've got a state-of-the-art facility in Bristol doing that, for instance. And if we move to the next slide, you'll also see that we're investing quite a lot into electrification. So we really want to go towards sustainable power. And in fact, yeah, COVID has been extremely challenging for us, but it did accelerate a few of the sustainable initiatives. And we can see that electrical flight, for instance, is becoming something that is more and more of interest. So we want to deliver cleaner power, more sustainable power, as it says here. To do this, technology and really top-notch manufacturing is paramount. So if we go to the next slide, the way we achieve this is to leverage. You can go to the next one again. So we have to leverage digital, you know, to achieve what we need. What we tend to say is, you know, what we're working on at the moment is what we can do in the future. So we're working on things. That's why there is 2035 on the calendar there. That's the sort of timescales that we're looking at. So when we do R&D, is for the next generation airframe, which is going to be, you know, 10 to 15 years from now. So you really need to understand today what's possible in the future. We've been using data for a while, and actually, if you think about data analysis, data-driven insights, optimization using data, we were one of the first to actually launch Power by the Hour, or what's called in the business our total care contract, which means that we actually own the engine, and it's like a lease to an extent to our operators. So we take care of everything. They pay $1 or an amount by the hour, as it says, and we take care of everything. To do that, we had to ensure that we could optimize our operation. And I still remember when the first time we set up the ops center in Derby in the UK, in the headquarters. It was pretty impressive to see all our engines in the world flying and seeing the parameters in real time. So all these parameters are then downloaded, and we can optimize the time on wing. We can optimize the engine removal for maintenance. So it benefits the customers and it benefits us. So this sort of digital solutions, we've been using it for quite a while. If we go into the next slide. So what we wanted to do, so yeah, just a quick example here, a few numbers just to confirm what I was saying. You know, the sort of number of engines we're looking after, tens of thousands, you know, now it's more than that, you know, nearly 5,000 aircrafts, you know, 80 ships around the globe, because that's something that I didn't mention necessarily. Actually, I think I may have missed one slide, but it doesn't matter. So we're doing power for planes. We're also doing power for ships. We're also doing power for trains. So we've got traditional engines, combustion engines that go onto land-based application or marine applications. So here you can see that we monitor in the same manner quite a few of our ships. All the service events have to be processed, so 25,000. All in all, what we're saying here is that we process millions of data points per day, and we have to have the analytic solutions that actually back this up. So what we wanted is to continue leverage these solutions into our manufacturing environment. So if we go to the next slide. Yeah, that's just, again, to give a little bit of context, what we're trying to do with our total care contract and everything that I've just presented, our operation rooms, is to keep our products in service on wing, and to minimize the time between, to maximize the time between overhaul, and to minimize the amount of overhaul that we have to do. So for our civil fleet, for instance, that means that the engine stays on wing, the equivalent of flying to the moon and back about 14 times, which is, quite significant. So I thought that was a good example to use. So if we go to the next slide. Yeah, so number one is what I've explained. We've got 24/7 operational support. We can use things like ship intelligence, and we've started to use the equivalent of what is now commonly known as a cloud. So server-based systems, we started to use them a long time ago to do a level of analytics and data insights, and a level of dashboarding. As I said, the operation room in Rolls-Royce was very useful to immediately get the information displayed. So what we wanted is to leverage this knowledge and apply it to our manufacturing, to our plants, and to our supply chain. We also started to use more and more this data to do end-to-end, to have a end-to-end digital thread, which includes the design. So if you think about it, if we know how we manufacture our products, we know how they operate in service, thanks to number one. If we use more digital input in the design, then we have a full understanding of the life cycle of the solution, and then we can improve the design for manufacturing. We can improve the design for operability, or design for services, and we can feed how it interacts with the method of manufacture. So certain features of the manufactured product will have an impact on the operation and service, and therefore we can feed that back into the design and improve. So it's a full ecosystem. It was enabled by the Internet of Things. Historically, we've been trying to, so in the manufacturing environment, the challenge that you have is that you've got a lot of different machine providers, you've got a lot of different protocols to be used, and the connectivity between these machines and the platform is always challenging. So historically, we've been using MES, the manufacturing execution system, to do this, and it's difficult. It's been demanding for us to. We always had to do tailor-made applications, sometimes to link one machine type to the MES. So it became very time-consuming to just enable this connectivity. If you think about it nowadays, it's a lot different. So I think if we go to the next slide, you'll see a little bit more what I'm talking about. The use of Internet of Things, or IIoT, Industrial Internet of Things, has changed quite a lot what we can do in terms of digital manufacturing. The sort of new sensors that we've got access to, we're developing energy scavenging sensors, for instance, that actually use the vibrations of the machines or the vibration of the engine to self-power themselves. So you don't have to bring wires to actually, you don't have to be intrusive either into the machine or into the component. It's Wi-Fi transmission, so you can place the sensor and then you can just download directly the data. all these sort of new communication protocols that are faster as well. So, we're talking about 5G now, and you can segment the 5G network, so you can actually completely segregate your communication channels. All this was impossible even a few years back. So really what we have now is technology that is a true enabler of obtaining a very informed method of manufacture. So before, the challenge, as I said, was the connectivity. The challenge was sometimes to gather the data in the right place through the sensors. High temperature electronics is another one that you can see on the screen. So, we can put now sensors in places where we couldn't before. So all this really gives us significant advantages to do big data. What we need to be careful is big data is not you need to pragmatically apply your industry 4.0 principles, I think, and you need to be careful that you don't overdo it. There is a lot of hype around industry 4, and I think you can also, if you go too far, make the mistake of sinking too much capital investment and too much investment in general into overspec'd solution. I'll touch on that in a bit. So if we go to the next slide, I think that just explain quickly how we can now apply these solutions very easily. So you can actually merge, thanks to the IoT architecture, legacy communication systems together with the new on-premise clouds, for instance, or general cloud-based data. So you can actually through a gateway, you can actually exploit everything you have available. So whether you use a traditional FANUC or Siemens controller and you get the data from the machine through those, or you add some specific sensors, and you gather additional data, you can aggregate everything through the gateway, and you can then decide, where do I want to do my analytics? Do I want to do them at the edge? Or do I want to push everything to the cloud and then leverage the analytic solutions that I've got available to me on open web architectures, for instance? Now, why is there a little lock on the cloud? Obviously, you need to be very careful with cybersecurity, so that becomes a very important point. For a company such as Rolls-Royce, which traditionally, if you want to be safe, you keep everything indoors, so you don't share anything. Web services and access to cloud was a big challenge, so we had to convince the relevant people that you can put things on the cloud, it can be secured, there is a good IP protection, and it's not as dangerous as people initially think. But it is a very hot topic. So once you've decided which analytics you're going to do where, then you can leverage the platforms and ensure that you generate this full end-to-end method of manufacture, where you can actually monitor each step and understand whether your product is good or not. So if we go to the next slide, an example there, I'll mention more, but so FanBlade. Well, actually, before I mention this, I should explain the plants that we have in Singapore. So in Singapore, we've got two main plants. We've got one manufacturing titanium wide core fan blades. So those are the blades that you see if you climb into a plane from the tarmac and you look at the engine, you will see the fan blades at the front. This is this is proprietary method of manufacture from Rolls-Royce. Historically, it was only manufactured in the UK. Singapore is the first place outside of the UK where we decided to manufacture these components. And the reason is simple: there is very good IP protection in Singapore. So we've got a plant which will become the lead plant actually for FanBlade, thanks to the projects that we've done in smart manufacturing. That will become the plant that will furnish most of the fan blades for all Rolls-Royce engines, in the future. So it's a significant achievement. This has been decided recently. So this consolidation is very good news, and it's actually testament to all the work we've done on this program that I'm going to mention, since 2017. So One of the operation, which is close to the end, is to linish the blade. Linish is not very, maybe it's a Rolls-Royce word a little bit. So it's a polishing operation where we use ABB 6000 series robots that hold a specific polishing head with a belt, polishing belt, and that goes across the blade and finishes the part. Our wide chord fan blade, they have a very thin, they are hollow inside, which is a very specific design, which allows us to save a lot of weight. So we're as light or even lighter than some of the composite fan blades of our competitors, and that's thanks to this design. Now, the issue with that is that you have to be very, very specific in the amount of material that you remove through the process. So we call it skin thickness because it's really like a skin. And initially, so those machines, we've got 8 of them, fully automated. We wanted to ensure that we were setting up the right predictive maintenance for those machines to ensure that they don't become a bottleneck. So we've done everything that I've mentioned before. Install the sensor through an IoT gateway. We use an on-premise cloud, and then we wanted to just use this to do predictive maintenance. I said just because actually when we finished the job, we realized that it was worth most probably going into something with a slightly higher sampling rate, which will give us the opportunity to spot issues very quickly and do correction of the process if we can. Obviously, if there is a real problem, stop the process immediately. Because what we've realized is with the additional sensors that we've put on the machine, we can, within a matter of seconds, detect whether there is a problem with, for instance, the blade that is not fixtured properly. The force sensor will detect that, at this point of the program, the force is slightly different from the usual. The angle also seems to be slightly different. Instantly, will stop the program. So that will save rework. So there is an alert, obviously, that is generated. That will save rework, or even worse, a scrap part. So, scrapping a part towards the end of the method of manufacture is the worst thing that you can do. So we went on a journey where we were planning to do predictive maintenance, making sure that we were actually checking on the machine. We ended up doing something a lot closer to real-time monitoring because it was worth doing, and we realized that we could save more components actually than we thought because of the quality of the signal we were getting, because of the quality of the analysis. So the analytics could spot straight away, a difference and stop the machine quicker than what we thought actually. So that's just an example. If we go to the next one. Okay, so I've talked a lot about the technology, how this is helping us to develop our solutions. If you do that on your own, that's great because you protect all your IP and nobody else can see what you're doing. It's also very expensive. So what we've decided with Rolls-Royce is to use a little bit more sort of partnership model. And this partnership was created back in the UK in early 2000. So if you go to the next slide, I think I'm talking about the technology readiness level. So technology readiness levels is the way we mature technology in Rolls-Royce. In fact, it's the way we mature technology in Rolls-Royce, but this technology readiness scale that you see on the screen, or the technology maturity, is not something that we invented. We actually used it from NASA. And this scale from 1 to 9 is something they've used to develop most of their products for all missions, recent missions for sure. So what that does is it allows you to gate the development of your technology. So if you've got a new idea, something that you would like to use is low TRL, which means it's in the area of 1 to 2. So I've got a new idea and I think this could be applied into the shop floor, for instance. I then mature this technology from 1 to 4 into a lab environment, or in our case, what we call the UTCs, University Technology Centers. So we've got them all around the planet, as you can see. One was mentioned by Bob, is Nanyang Technological University in Singapore. We've got some, for thermofluids. We've got some for fluid mechanics in, Chalmers in Sweden, for instance. You name it. We've got a lot in different places. So we mature this technology in a sort of lab environment with universities, with PhDs, with people and the professors and people. So we generate publication, we generate IP, and we mature the technology towards something that could be used into a manufacturing environment. But what we noticed is that it's fine to develop something all the way to level 4, but then it's quite difficult. It's a leap. I think everybody can see that it's a leap to go from a lab in a university to a shop floor. And these level 5 and 6 in light green at the middle of the screen were called the valley of death, because it was falling regularly. This technology didn't pull through, so it was falling in the valley of death, and it never made it to the production floor. So we started to develop these research centers. The first one was in Sheffield, so it was with University of Sheffield. Boeing was keen to do something of that nature. We joined, and then a few other people joined. This area in Sheffield now is completely different to what it was when we started. We've got McLaren came. A lot of people are now using this model, because you realize that a lot of people have similar problems, but so long as you develop a platform technology that you can use, and then you do it for your products in isolation, you don't need to protect everything that you do from A to Z or from level 1 to 9. You can actually share the knowledge and collaborate from level 1 to 5. And then once it goes onto your product and into your production, into something that is very specific to you, then you can bring it into your shop floor or into your own development cell, and then finish maturing the technology. So this smart program that we have is actually aiming at doing just that. Taking the technology that we develop in the corp lab, in the corporate lab with NTU, test it onto relevant machines, industrial machines, before it's actually, and then modify it in some instances, finesse it until it can be implemented in our shop floor, in Singapore, for instance. So what we've done with these technology centers is making sure that we bridge this valley of death. What we've done with smart manufacturing in Singapore is we've accelerated the way we develop technology by using agile program management on top of this, research center capability. So if we go to the next slide, I think there is an example. Okay, sorry. So it's not exactly in the order that I thought. That's okay. So just to continue building on what I just said, so R&T in Singapore. So on the left-hand side of the chart, the 1, 2, 3, 4 level, the red gates. This is what we do with our corporate lab at NTU. So what Bob mentioned during the introduction, you can see the investment is pretty significant, 160 million Sing dollars. And I'll take you through a few aspects of what we're doing. I'll do that very quickly. If we go to the next slide, this lab actually develops a lot of the hybrid electrical power. So I mentioned at the beginning of the presentation, we need to go green, we need to go, more sustainable. And that's really half of the projects that we have in Singapore with NTU are to do with that. So how to develop new power converter solutions, for instance, generators, new battery types to enable these things to happen. So then we can have hybrid trains, as you can see, hybrid boats. We can also have microgrid solutions where we've got gen sets. So those are our engines, like diesel engines, that can be complemented with PV, with wind. And recently you would have seen that we're also investing in SMR, which is small modular reactor. It's like a micro nuclear power plant. So all these things will require dynamic load management and distribution of this power to the relevant places. So that's one aspect that we're doing in Singapore in the Corp Lab, and we're also doing the application. So those are land-based application or marine-based application, as I said. If you go to the next slide, we're also doing the same for airborne capabilities. So as you can see here, we're developing more and more eVTOL concept. So this one was revealed in air show a few years back, and so it's all these applications that I've mentioned that we now leverage and tailor for an airborne application. So you need more power density, and you need obviously lightweight solutions. And we're very well placed to develop these solutions, because at that point when we go into airborne solutions, as I said, weight is a very important point. And thanks to additive layer manufacturing, 3D printing in other words, we can really achieve new structures that we could not manufacture before. So that's a lot of the work, is to do new battery packs and enclosures using 3D printing systems, increase the power density of the solutions through new cooling mechanisms as well. So yeah, there is a lot of activity going on new manufacturing technologies for these kind of applications. So we test them in the lab, and then when they start to be mature enough and we think we should see whether we can manufacture those in a representative environment, that's where we move to the smart manufacturing program. So if you go to the next slide. So as you can see there, the robot that I actually mentioned in the presentation earlier, the ABB 6000 series, that's exactly the same robot that we've got in the Advanced Remanufacturing Technology Center. So that's a technology center owned by A-Star. And what you see here is one of our components. So this becomes very real and very transferable to our plant. So once we've tested the technology in this environment, it becomes very easy to push it into the plant. We can even transfer the programs in some instance. We don't even have to rewrite anything. So that's the power of this ecosystem that we've developed in Singapore. We've got very strong academic support at NTU, looking at state-of-the-art technologies. We then transfer those that are making it through, and the most promising ones, into our smart manufacturing lab, with A-Star, and then we push it in our lab, in our shop floor. So if we go to the next slide. The way we've done that is through gates, as I said. So that's why you've got the little panel there in the middle. So we issue the problem statements, we develop the technology, and we mature it. It goes through gates with the relevant people, so the experts, people from manufacturing. Finance is always checked, because you need to continue checking on your business case. So when you've got the idea at the beginning, you think it's gonna improve the manufacturing time by that much, for instance, you always need to constantly check that you're still on target. You do a feasibility study, and then you check whether you're actually about there. You check your ROI, and then if it's everybody is tick tick tick, then we move into technology transfer, and then we can implement in the factory. The technology transfer is obviously a lot more straightforward for the reasons that I've mentioned, because you're testing it onto an industrial network. So when we've tried implementing those sensors in ARTC, for instance, the sensor type was the same, the protocol that we used were the same. So when we put it in our shop, it just took a few days and we were live. So all the debugging can be done into those research centers. So if you go to the next slide. Okay, so before I go into the sort of ecosystem that we've developed, I think what's also very important when you do digital manufacturing and this sort of new technology development is to be pragmatic and to start small to an extent and then ramp up. I've I've had a lot of technology providers coming to me telling me, look, what you need is the full suite. You need basically Industry 4.0 is going to resolve all your problems. It will resolve some of the problems, but if you're not careful, you're going to end up spending so much cash. And data is really nice, but you need to store it as well. So you need to be very careful about, the amount of server space that you're going to end up using, cloud solutions that, you will have to buy, the space and the licenses and all these sort of things. So you really need to do a value stream mapping of your method of manufacture. You need to identify the bottlenecks or the process that are really critical, like the one I've mentioned earlier. And you need to say, well, on that one, I'm going to go full stack, which means, I'm going to go with a sampling rate of 25 milliseconds, for instance. I'm going to try to do real-time data monitoring. I'm going to invest a lot into developing all my algorithms and the machine learning and the AI solutions for that process, because it's a critical process. And if that doesn't work very well, it's going to have a big impact on my scrap. It's going to have a major bottleneck, create a major bottleneck in my line. You don't need to do that for all processes. I think some of the processes is perfectly fine to just do a sampling rate of even 4 or 5 seconds if you can afford that. Just check that every 4 or 5 seconds your process is within limits. Just make sure you define your key process variables very accurately so that so long as I'm within those on those key process variables, then my process is good. Then your output of the operation, and that's fine. You ensure that you've got the time stamping that is writing onto the MES, downloading the KPVs that you've extracted, and then you've got your electronic batch card that is then done. And you don't need to do more than that. So you just need to ensure that the connectivity between your operations is there so that you can have this visibility through the method of manufacture. For critical processes, you will deep dive, as I say, and you will go and implement the full suite. And that gives you the sort of overall setup that, I've changed the light. That gives you the overall setup that you'll be using for your digital manufacturing. So I just wanted to explain this because I did mention that adopting a pragmatic approach is important. And as I said, you need to be careful because a lot of solution providers show you that everything works. In my experience, it works on PowerPoint. It doesn't work when you transfer the technology on the shop floor. Again, that's one of the reasons why having these research centers is good, because you can then test it for real. So without naming names, I've had solutions that should have been, or systems that should have been communicating very, very easily because it's from the same provider. It didn't, and then it took us actually a little while to understand why. You can't afford to do that when you're running in production. And what's interesting as well, and that's why we've got this slide in front of us, is these research centers, they allowed us to find gems in the sort of Singapore ecosystem or Singapore SMEs, so small, medium enterprises. People that would not necessarily have had access to Rolls-Royce, or it would have been difficult for them to demonstrate their capability directly to Rolls-Royce. In the research center, we've been able to invite them, get them to show us what they can do. And as it says here, when we signed the joint lab in September 2017, we had about 3 of them. Now it's beyond that, actually. I should update the slide. In 2021, we're beyond 100. So we've really developed this very powerful ecosystem where, we use big providers when required. We use SMEs to help us on very specific aspects, and sometimes we can also offload some of the work. One thing to keep in mind is when I said you on one key process, you go the full suite. It takes time and it takes resource to identify your variables, do feature selection, which is what you're going to use as a basis to do your algorithm. Actually write all the algorithm and the machine learning, all this is very time consuming and resource consuming. So again, it's very good to have good allies and people you can rely on to offload some of the work packages once you know that the process that you've selected is critical. I think we can go to the next slide. Okay, just a few examples, I think, to wrap up, because I think I used quite a bit of time. Let's go to the next slide. Just to make it a bit more real, I think I've got a few images. So all this is in the shop. So all this has been implemented. Some of them implemented in record time, actually, a year. For some of you, it must be, maybe it sounds very long, a year to develop a technology from a concept to implementation in shop floor. I'm sure some people on the call do that much faster, but for aerospace, it's quite demanding because we've got a lot of regulation and we have to get the process certified, by the authorities. So, a year to actually go from a concept into full prod is very, very good. Few examples, when we manufacture fan blades, we have to print a pattern on the titanium sheet or panel, and this pattern has to be inspected. All this was printed in a clean room environment, and it used to be inspected by a human. So the guys have to be fully kitted up because it's a clean room environment. They are checking a panel that is about 1.2 meters by 650 millimeters, and they're looking for defects that are the size of a human hair, roughly 150 microns. So you can imagine how demanding that is. So we've used a digital camera system together with AI and machine learning algorithms to actually scan the blade very, very accurately and detect any defects that you have, and then run the algorithm to issue summary of the inspection. So not only it's more accurate, not only we can avoid the guys having to scan a big area visually, we also have all the data available. So thanks to what I've said, you can actually correlate the operations and the method of manufacture, and you can actually see whether a defect that could happen later down the method of manufacture, there was already something that could have happened at the beginning. You can be a lot more instructed and a lot more intelligent about the whole of your method of manufacture. So as soon as you go digital, you've got all this available. Before, it was just a stamp on a batch card. The inspector said, yeah, it's good. That's it. You can't dive into the data if you need. The printing is the same as actually the operation just before. The printing was done manually, and then we realized that trying to develop a solution to do the printing like an inkjet printer would be a lot better. We had to develop the head, we had to develop the systems to accurately position. The jetting was the challenge in that instance because the compound that we use is a ceramic compound, and therefore is very difficult to eject. Another couple of examples, if I go to the right-hand side, we had to mask the blade before putting it into etching, which is a hydrofluoric acid tank to remove some material. All this was done manually. Now it's a robot system with cameras. Again, thanks to the data that we collect, we've got a lot more data points that we can use. Before that, there was no data collected because it was applied with a brush. And what we've done also regularly on the process is in-process measurement. So as you can see, so each time we fixture the blade, we should try to avoid removing it to take measurements. The more we can do with the blade on, the more we maximize the accuracy of all the operations, the manufacturing operations that we are carrying out. So if we can measure everything without removing the blade and repositioning it, then it's actually more efficient. So again, this has been done on the robot systems that I've mentioned. We're collecting all the data, and it builds our data model through the method of manufacture. I think I should stop here. I think I'm done anyway. Have a look, the next slide. just showing, yes, this works really well for everyone. This is our colleagues from the Singapore government agencies. So yeah, very successful program. Thank you. I think that's it.
All right, thank you very much, Luke. That was a fascinating presentation. I just have a couple of questions, and I think then we'll go to the audience, given the time constraint. But I think you mentioned Power by the Hour and Total Care Contract. I think in terms of service innovation, Rolls-Royce was very early in the game. So when it comes to manufacturing, was there a particular driver to adopt advanced, smarter manufacturing within the company?
Yeah, I think it's really, you know, the understanding of the method of manufacture became something really strong, and what I've mentioned really proved that it was the right route. So I mentioned that now we are consolidating the manufacturing in Singapore. It's really thanks to that. If you fully understand your method of manufacture, you become a lot more efficient. So you know, the UK plant will have to be upgraded to the same standard. That's why we are now getting more you know, more manufacturing done in Singapore, is thanks to the digital thread. So enabling this will, you know, generate less scrap, you know, more proactive process. You know, we basically, the efficiency of the plant is significantly different from the sister plant in the UK. So the drive was really to achieve, you know, operational effectiveness and efficiency, and we've really proved that it was the case.
And is this a global program? So you have similar things going on at other Rolls-Royce plants around the world, or was it particular for Singapore?
So we implemented, so because Singapore government is helping us a lot, the condition was, you know, you make the Singapore plants, the flagship plants in the first place. After that, we can read across. So all the learning that we gained through this program are now being implemented in other plants, you know, so one in the UK. Okay. Some of the other operations that are not fan blade specific are also read across into some of our German plants.
Okay. So Singapore was really the leader in this, which is good to hear.
Yes, absolutely. Okay. Yeah.
Okay. The other thing I wanted to ask you was you talked a lot about partnerships and research centers and cooperation.
Yeah.
And I guess that must involve quite a lot of management of your partners. And given that you're looking at technology transfer, how do you make sure that the work that's being done outside results in new and improved organizational capability within the company as well?
Yeah, so the way we contract all these projects is very specific in terms of where we draw the line on the IP. So some of the what we call platform technology, we think, well, anyway, this is going to become critical only when we apply it to our product. So in the research centers, there are, like, you know, P&G is there, Nestle is there, Coca-Cola is there. You know, we've got, and we're very happy to share you know, some of those technology with them, because, you know, if they apply it to can manufacturing, then that's great. But, you know, it's got nothing to do with fan blade manufacturing. And then similarly, they will do some projects that we're interested in, and they don't mind because it's a completely different industry. So in the project, it's done in phases. And as soon as it becomes applied to our machine, our product, and we think that, you know, this is something critical for us, then we own all the IP. And sometimes we actually ask them to do it in a specific area that the other members cannot see, or we actually transfer it to our plant and we test it in our plant. So it's through the contracting that we actually protect, you know, what we need.
Okay, just one last thing before I hand back to Raman. And you also mentioned this, that the aerospace industry has been under a lot of pressure the last year, and I think we all know that how tough it's been for the industry. So has that affected in any way your smart manufacturing program? Has it affected investment in that in any way in Singapore?
So where we've been extremely lucky is, as soon as, and you know, you live in Singapore, so I'm sure you're very well aware of that. As soon as the government saw what was happening with, you know, no more flights, instantly they understood that, you know, Rolls-Royce was going to get impacted, and they decided to help us. So they said, you know, what do you need us to do so that we can sustain these programs? So,
Okay.
you know, they helped us significantly. So this is a blessing. So the answer to your question is no. And it's really thanks to the proactiveness of the government, because, and for us, it's been fantastic, because that meant that we don't have to slow down on those. That meant that in turn, we can continue using the new plant as we were planning to use. So this could have been slowed down last year or even stopped completely. It didn't happen, thanks to the sort of trust, you know, from the government and help from the government. So that was very, very good.
Okay, excellent. Raman, do we have some questions from the audience?
Hi, Bobia. We have some questions here. We have a question from Surendran Kandaswamy. Since all the applications solutions are likely coming from various vendors, technical providers, how do you standardize the deployment? Do you share edge gateways? Are there certain specifications for the IoT devices?
Yeah, very good question. Yes. So what we've done, so initially we didn't have that, because in fact the Industry 4 standards are being developed as we speak. You know, there isn't one specific way to do it at the moment. So we actually developed it through the learning that we've gained with those providers. So yes, now we've got a specific type of gateway, or even brand of gateway sometimes, that we advise. We're trying to use always the same protocols. You know, OPC UA, for instance, is very good for us. You know, we've tried a little bit MQTT, but, you know, OPC UA protocol is really giving us good results. The type of platform and communication, the way we actually do the analytics, so we can decide to have several people coding for us. We've got like coding guidelines. So, you know, it follows the same. So it becomes a bit agnostic to who is doing it. You know, we've got a standard template that we're using. So whether it's supplier A or supplier B is fine. And then it's also always recognized by the Rolls-Royce manufacturing engineers. So, you know, it needs to be maintainable by us. So yeah, you have to set your standards. And it's through the learning and the projects that you do that you actually create your specs. And you know, once you've got the specifications, you just use that with everyone.
Yeah, we have one more question from Raven Chavatia. Can we develop power plant spare using 3D printing system, metallic as well as plastic?
Yes. So yeah, that's a good. So when I was talking about ALM, it was mainly for parts, actually. So for components, improved capabilities of components. But yes, we've been looking at tooling as well. So yes, that's something that you can do. You can do prototyping and tooling, and that's something that we're gonna look into a little bit more, actually. We used it straight away for the components because we saw the application potential. But yeah, once we've done quite a few components, I guess we'll also be looking at tooling. So yeah, tooling special to product, we call it special to product tooling and fixturing. So those fixtures that you use for machining, for instance, all this is on the roadmap. And in fact, with the 3D printing, you can also insert some sensors in the tooling or in the fixturing, which can be very powerful. So yeah, that's something you can look at.
We have the next question. The next question is on the in the presentation there was a comment about COTS, commercially off-the-shelf component being used. And then how are you ensuring that these components are provided for long-term support? Because in the presentation there are comment about billions of IoT devices will get connected. So how are you ensuring that these components are supported long-term?
Yeah, actually, that's something that we're looking into, and that's something that is a little bit more challenging. So what you need to answer is that, you know, the protocols are standard protocols. So communication should be following the standards that we mentioned. I think what we're experiencing now is some challenges to do with battery replacement, or, you know, issues with the sensors. That's actually a good point. And so far we've been quite lucky. You know, the systems that we've decided to put into production have been reliable. The debugging that we did in the research center was really helpful, and we didn't run into situations where, you know, it goes into production and everything falls apart. We've had very good continuity, and things have been sustainable, but that's something that you need to keep in mind. So a bit careful when it comes to using, you know, startups, or, you know, some technologies can be very good. You then need to decide, okay, am I going to ask for a known integrator to, you know, license the technology and use this from the startup, for instance? Because as you say, if you start to go into some specific solutions, you need to think about the life cycle of that, and you don't want to put this into prod and then have a situation where it falls apart because, you know, you can't maintain the solution. So yeah, something that you need to be careful about.
Thanks, Lux. Almost, Bob, I think we have come to the end of the session now. There are some more questions, but I think we'll not take them further. I'll ask Lena to put a formal vote of thanks. Thank you all. Okay.
Okay, thank you.
Thank you very much.
Yeah, thanks, Bob and Luke. We thank our speaker, Luke Shepard, Chief of Manufacturing Technology, Rolls-Royce, for participating in the and looking forward for your support on the upcoming events. Finally, we thank ARC Advisory Group India team for all logistic supports. And we have an announcement from our side, from ARC. So the next tentative event for DTC Asia will be on 29th April 2021. And we also have our regional forums scheduled, online virtual forum, Europe virtual forum on May 18th and 19th, 2021. We have Asia virtual forum likely from 12th to 14th July 2021. And we have our US forum in February 2021 completed. So if you want to log in and view all the videos of our forum, which has happened in February, please log into our US forum website, and we'll be sending you the link for the same. So thank you all for participating in this event.